In my last video, I talked about how chemists have figured out trends in order to help us predict chemical reactions. We have already covered synthesis reactions, and if you're needing a refresher on that, click the link above. With that being said, let's dive into our next video of types of chemical equations. The next type of equation that we're going to discuss is decomposition reactions. Decomposition reactions are quite literally the opposite of synthesis reactions. We start out with a singular compound on the reactant side, and it is broken down into its components on the product side. So we can write this equation as AB yields A plus B. To illustrate what this looks like, think about you and your significant other breaking up. You are a couple, in other words, a compound on the reactant side, and for whatever reason, both y'all decide to break up with each other and become strong, independent people. These are the individual elements on the product side. When approaching these types of equations, it's important to know keywords to look for to tell us that, hey, it's a decomposition reaction. Obviously, the first word that would indicate this type of reaction would be decompose, or some variety of that, like decomposition. Another word that can indicate something's being broken down is electrolysis. Electrolysis is the decomposition of a compound using an electrical current. Finally, as I've already alluded to, a compound can be said to be breaking down or be broken down. That's probably a good chance that it is a decomposition reaction. Now let's jump into some examples. But let me warn you first, I'm not going to hold your hand as much when it comes to balancing equations. I'm kind of just going to go through them with it. If you're still needing help with this concept, please click the link at the top of the screen for some other videos on balancing equations so you can get some help and then come back to this video. Like the synthesis video, we are going to start with water. So here's what a decomposition of water question may look like. Write the chemical formula for the electrolysis of water. So I look at this question and I see that water is being broken down. This means water is going to be the compound in my reactant. So I would start my equation out by stating water yields blank. Then I would look back at my compound and think, what are the components of this compound? In other words, what makes this compound up? I see water is made up of hydrogen atoms and oxygen atoms, so they must be in my products. I then go to my equation and add my pure elements to the product side, H2 and O2. Remember, oxygen and hydrogen are both diatomics. This is why they have a subscript 2 paired with each of them. Now I can start balancing this equation. I do this by putting a 2 in front of the water molecule on the reactant side to account for the oxygen on the product side. I then add a 2 in front of the hydrogen on the product side to account for the now 4 hydrogens on the reactant side. So our new chemical equation is going to look like this. 2H2O yields 2H2 plus O2. Let's work another one out. Write the chemical equation for the decomposition of aluminum oxide. We start out by writing aluminum oxide, so Al2O3. Then we decide what are the components of it. Well, I see that there's aluminum in it and oxygen in it, and I don't see anything else. So these must be the components that make up this product. I add Al plus O2. Now I can balance my equation, and I get this answer. 2Al2O3 yields 4Al plus 3O2. The final example in this video is going to be writing the decomposition reaction for nickel 3 oxide. We start out by writing what we know as our reactant. So first is Ni2O3 yields. Then we break it down to its components, nickel and oxygen. Finally, now that we have the backbone of the equation, we can start balancing it. And we get 2 Ni2O3, or 2 nickel 2 oxide, yields 4 nickel atoms plus 3 oxygen atoms, or 3 O2s. With this information, you can start practicing decomposition reactions on your own. As always, I hope this helped you out and keep up your good work. Thank you for watching this all the way to the end. Don't forget to hit that like or subscribe button if you haven't already. If you're one of my students or just want to watch related videos to this topic, click the playlist button on the right side of this screen. If you're just wanting to keep up with this channel, my latest video is going to be posted to the left of the screen. Once again, hey, thank you for supporting this channel, thank you for supporting me, and good luck this year in your classroom.